Today, we're diving into a war that's been raging for thousands of years. It's not fought with guns or bombs, but with secrets and codes. This is the unseen arms race of cryptography in warfare.
I mean, think about that for a second. What if the most important battles weren't fought on a field, but over the ability to hear a secret, or to keep one?
Well, the thing is, they are. From the ancient world right up to the digital age we live in now, the power to protect your own information while cracking your enemies has been an absolute game changer. This is that story. All right, so where does a story like this even start? We've got to rewind the clock way back, because this fight for secrecy is just about as old as conflict itself. You know, it all started with some pretty clever but physical tricks. The ancient Spartans, for instance, used a special rod to literally jumble up the letters of a message. Then you had guys like Julius Caesar, who used a simple substitution cipher, basically just shifting the alphabet over a few spots. Jump forward to the 16th century, and the Vigenère cipher made things way more complex with a keyword. But the real leap, that came when machines got involved.
And all of that leads us to the big one, the ultimate challenge of its time, the German Enigma machine. In World War II, this thing was the absolute peak of secret communication.
So what made Enigma so tough? Well, its system of rotors and plugs created a truly astronomical number of possible settings. For the codebreakers at Bletchley Park, trying to guess every single combination was just impossible. Breaking it was going to take a whole new kind of thinking. And they did it. They broke the code. The intelligence they got from it, codenamed Ultra, was just mind-blowing. It gave the Allies this incredible window into German plans and troop movements. And here's the crucial part. This wasn't just some academic puzzle they solved. Breaking Enigma directly translated into shortening the war and saving an unbelievable number of lives. But you see, the work at Bletchley Park didn't just end with the war. It actually set the stage for a whole new kind of conflict, one fought with silicon and algorithms, instead of clunky rotors and wires. Okay, now this is where things get really interesting and kind of counterintuitive. There's this core idea called Kirchhoff's principle. And basically, it says you can shout from the rooftops how your lock works. The design can be totally public knowledge. The whole system is still secure as long as nobody else has your specific key. This is what lets us build super robust open systems that everyone can test. And building on that, a genius named Claude Shannon gave us the two pillars of all modern encryption. First is confusion, which just means scrambling the message so thoroughly there's no way to see a pattern connecting it to the key. Then there's diffusion, and this is the cool part. It means if you change just one single letter in your original message, the entire encrypted text changes completely and randomly. It's like an avalanche effect that makes the code incredibly hard to crack. So today, we basically use those ideas in two main ways. Symmetric encryption is like your house key. You and a friend both have a copy, it's super fast for locking and unlocking, but you have to find a safe way to give them that key in the first place. Asymmetric, on the other hand, was the real revolution. It's like having a mailbox with a mail slot. Anyone can use the slot, the public key to drop a message in for you, but only you have the private key to open the box and read it. This lets two people who have never even met talk securely. Okay, so we've got the theory down, but how does all this powerful tech actually play out on a modern battlefield or in the shadowy world of spies? Let's take a classic spy movie example. An agent in the field writes up a critical report. Their secure messaging app scrambles it into complete gibberish. Now that jumbled mess of data can be sent over the regular internet, totally out in the open, and it doesn't matter one bit. Because only the handler back at headquarters, the one with the correct key, can turn it back into readable text. And look, that's just one tiny example. The truth is, cryptography is the invisible armor of the modern military. It's everywhere. It's what secures the data links between jets and ships. It protects the radio chatter between soldiers. It encrypts the video feeds coming back from drones and satellites. It even makes sure the software update for a missile system is legit. If it's digital and it's military, you can bet it's wrapped in layers and layers of math. But here's the thing about an arms race, right? It never, ever stops. Just when we think we've built the perfect unbreakable lock, someone out there starts building a brand new kind of key, and that's the next front in the secret war. All these digital fortresses we've built, especially the public key ones, they rely on math problems that are just too ridiculously hard for our current computers to solve. But what if a totally new kind of computer came along? Well, that new kind of key is being forged in labs right now. It's called a quantum computer.
And so what happens? The arms race continues. The world is scrambling to develop what's called post-quantum cryptography, or PQC. This is a massive global effort to invent entirely new kinds of encryption based on math that we think will be hard for even a quantum computer to break. We're in the middle of a planet-wide security upgrade, and most people don't even know what's happening.
Which brings us right back to where we started. From a simple Spartan stick to the mind-bending power of quantum mechanics, this has always been a battle over information. And as technology gets faster and more powerful, this hidden war only gets more important. So the real question is this: in the next war, the one fought with data and algorithms, who's going to be holding the unbreakable key?